Hello, Mr. Hausel here. This video is for test prep for Chapter 8, Functions and, Exponents and Functions. What we're working on, this one is specifically EO14, Operations with Exponents. So operations mean add, subtract, multiply, divide, with exponents. So write the following in positive exponents. When I'm done, every exponent has to be a positive exponent. Can't have any negatives. So what I'm doing here is I'm multiplying this quantity by this quantity. This one is being raised to the third power. So I have a negative x raised to the third, y raised to negative 5, all that multiplied by negative 4x to the third, y basically to the first, and then that is being raised to the exponent to the third power. So I'm going to go ahead and solve this, but I should also still be using DEMDOS. So grouping symbols, exponents, multiply, divide, add, subtract, in that order. So technically, I need to take care of cubing this expression. So if I raise this whole thing to the third power, that would basically be negative 4x cubed y times negative 4x cubed y times negative 4x cubed y. That's really what this whole expression right here stands for. And then that expression is getting multiplied by negative x cubed y to the negative fifth. Okay? So there are some shortcuts to this. The one shortcut would be, since it's negative 4, negative 4, negative 4, they're all multiplied together, I can just do negative 4 raised to the third power. You can use your calculator for that, or negative 4 times negative 4 is 16. Multiply that by a negative 4, you're at negative 64. So negative 64 is a way to rewrite these guys. And then inside, outside, when there's parentheses, you must multiply your exponents. So 3 times 3 would be 9. It would be x to the 9th power. And the reason that works is x cubed times x cubed times x cubed would make me also add those exponents. I still get 9 of them. X to the 9th. So those guys are taken care of. And then technically this is a y to the first power. We just don't take the time to write that first power. But at y to the first power, so inside, outside must be multiplied. 1 times 3, 3. Or y times y is y to the third. Okay? That is all being multiplied by this. So I did just take care of my exponents. There really was no grouping. I'm now on to the multiplying step. So multiplying this quantity by this quantity. Again, in math, there are some things that are implied. And it's implied that this is a negative 1. Kind of like that was implied that this is being raised to the first power. Right here, this is a negative 1x. So I'm actually going to kind of reorder everything. And I'm going to take my numbers and put them next to each other. And I'm allowed to do this because multiplication is commutative, which means you can change the order. I'm going to put my x's next to each other. I'm going to put my y's next to each other. It's still the same multiplication fact, but now there's just a different order to make it easier on me as I'm solving the problem. And the reason it's easier because now these guys, basically sort of like terms, but I can multiply them together. A negative times a negative is a positive, and I get 64. X cubed times x to the 9. That's like, I could expand it out. That'd be x times x times x. That's what x cubed is. Multiplied by 1, 2, 3, 4, 5, 6, 7, 8, 9 x's. So I just add up how many x's I have. Repeat multiplication is what exponents is about. And it's x to the 12th. Or I can just add the exponents when I'm multiplying. As long as the base is the same, I can add the exponents. So here the base is the same. Both of them are y's. I can add up those exponents. And negative 5 plus a 3 is a negative 2. I'm almost done except for this rule. I must have positive exponents. So I have all these things being multiplied together. And this guy has a negative exponent. That's a problem, according to this instruction. Negative exponents can be written as 1 over, and then turned into a positive exponent. Y to the second. Instead of a negative 2, being turned into positive 2. So that's actually what's being multiplied on the end here, is y to the second, or y divided by, or 1 divided by y to the second. So I can actually write the rest of them as fractions. 64 over 1, x to the 12 over 1, and multiply everything together and get my answer. So if I go across the numerators, and I multiply all those together, 64x to the 12. Go across all the denominators, multiply them together, 1 times y squared. I get y squared. I also get my final answer because now everything has a positive exponent. 64 over 1 is reduced, so I'm okay.